All right. Is this a binomial distribution? Yes, this is binomial. There seems to be a bit of a problem with which one of bins. The I. It seems to violate independence. Why are we allowed to get away with violating independence? Because we're sampling without replacement. I'm taking them out of the bag and I'm eating them. I'm not putting them back. 10% rule. So what's success, what's failure in this case? Cherry is the success. Failure is everything else. Independence, you said we can use our 10% rule, our 10% condition. So how many things are we sampling here? 200 out of, what's my population? Every starburst, period. Just every single starburst. Is 200 less than 10% of all the available starburst? Yes. 200 is less than 10% of all my starburst. And then N and S. What is N? 200 and S? Technically, we would call that P, right? But S is same probability of success each time, and that's 0.25. How do you find the mean for something like this? We said it is binomial, so how do you find the mean for a binomial random variable? N times P. What do we get when we do N times P? 50. How would you interpret that answer of 50? What does that mean? What did we just calculate when we calculated N times P? The average, right? Because a mean is an average. The average of what? The average of cherry starburst in a bag of 200. Because if I'm looking at like 7 bags, it's not going to be an average of 50. An average in a bag of 200. Give me some more. After many trials, is about 50 starburst in the long run. And I should add this little caveat. There we go. Starburst in a bag of 50. Or sorry, in a bag of 200. In a bag of 200. After many trials, is 50 starburst in the long run. Because in my bag of 200, am I guaranteed to get 50 starburst? If I buy 2 bags of starburst and I count all the cherries in each bag and I average those out, am I guaranteed to get an average of 50 per bag? No, but if I buy bag after bag after bag, I do this many times over the long run, I should end up with an average of about 50 starburst per bag. Since this is binomial, how do we calculate standard deviation? Square root of NP times 1 minus P. And what do we get when we do that? 6.124. How would you interpret that? What does that 6.124 tell us? The number of cherry starburst in a bag of 200 typically varies. Yes, the number of cherry starburst in a bag of 200 typically varies by 6.12. I wrote 5 instead of 4. 6.124 starburst from the mean of 50 starburst. Or I could write cherry starburst. I just started running out of room. And I did say cherry starburst right up here. The probability of getting exactly 60 cherry flavored starburst. What does this probability notation look like? Probability x equals 60. I know of two different ways to calculate this value. What's one possible way we can find the probability that x equals 60? Binom PDF. What do we need to feed a binom PDF function? N, P, and X. What's N? 200. P? 0.25. X? 60. So binom PDF with our inputs of 200, 0.25, and 60. Please make sure you label these. I cannot tell you how many times I've been grading AP FRQ questions, and a student will have something like this with the right answer at the end, but they don't have NP and X labeled, and one of the things they're looking for on the rubric is, did you correctly identify the number of trials? Did you correctly identify the probability of success? Did you correctly identify the boundary or the value of interest? If you label those, then you are showing that you understand what each of those pieces is and not just, I know I plugged this into the calculator this way. What'd you get? Yep. So about 0.0171 if you round it out. What's the other way we could calculate this if you don't do binom PDFs? Say you only have the app on the calculator to use and you don't want to pay for it. NCR, what do we put in for N? 200. And then what goes after the C? 60. Then what do I need? Probability of success, 0.25. To the power of 60, the number of successes that we want, times 0.75, probability of failure, to the power of 140. If we have 60 successes, we're going to have 140 failures. You should get the exact same answer either way. Or it should be close enough that nobody cares about the difference there. What does my probability notation look like for number 6? Probability of x is less than or equal to 60. Technically, there's two ways to do this one, but I would only recommend one, especially with an x value of 60 here. What's the best way to do this? Binom CDF. And what information do we feed into binom CDF? Number of trials, which would be 200. What else do we feed it? Probability of 0.25. We want our probability of success. And then 60, we have to feed it that x value. What do you get when you do this? Yeah, I got right about 0.955. Depending on how you round. I was doing this real quick, so if I rounded slightly differently than you, I apologize. The very bottom question said to redo problem 6, what we just looked at, with a normal distribution. To do this, n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. Didn't we already do n times p? Yeah, that's my mean. What was n times p? 50. That's greater than or equal to 10. So we're good there. What is n times 1 minus p? 150. It's greater than or equal to 10, so a normal approximation is appropriate here. Has anybody noticed the relationship between n times p and n times 1 minus p? In this case, they add up to what? 200. Why is 200 a special number in this problem? That's my number of trials. N times p plus n times 1 minus p will always add up to n. It's always going to add up to my number of trials. So once you calculate the mean, you should be able to figure out what n times 1 minus p is just by subtracting from your number of trials. If we do a normal approximation, what do you have to have every time? You need a diagram, you need a drawing. What should your drawing look like? You need your bell-shaped curve. What goes right down the center of the bell-shaped curve? The mean, which in this case is 50. What else does my drawing need? Needs a big capital N with parentheses. What do I put in the parentheses? Mean and standard deviation, they have to be labeled. Please, please, please make sure you label these. There's something else my picture needs. Shading, and I need a boundary line. Where should the boundary line go? 60, and then which way should we shade? To the left, because it's a less than. So your picture should look something like this. It is incomplete without the shading. When you do the shading, you are showing whoever's looking at the picture that you understand the direction of this inequality. Without the shading, you're showing this. You have to do the shading to show the inequality. All right, then we do normal CDF. Put in your lower bound, your upper bound, your mean and standard deviation. Please make sure you label all those pieces. When I shade to the left, I usually choose -1,000,000 for my lower bound because A, it's really easy for me to remember that number. And B, so far in AP Stats, I've never found a situation where -1,000,000 isn't small enough to capture as far down as I need to go. Same thing on the upper bound. I haven't found a situation yet where 1,000,000 fails to capture everything that I need to on the higher end. You don't have to use the same extremes that I do, but you do need to make sure that your extremes would be high enough or low enough to match the situation. What do you get? What do we get? 0.949, which is almost the same as my 0.955. They're both about 95%. Nice work on this one. We're going to do a little bit on page 19 now for a little bit of review with stuff that we did at the beginning of this chapter, because it's been a hot minute. We've been talking about binomial random variables for a while. We were just introduced to geometric, and I'm afraid we might have forgotten the other types of random variables. I want you to use your graphing calculators to do number 1 and number 2. I want you to find the mean, the variance, and the standard deviation for x, and then the mean, the variance, the standard deviation for y. So you need to use your lists. You need to do stat, edit, and then enter these values in your lists, and then stat, calc, one variable stats with L1 and L2. Remember, variance is just the standard deviation squared. Okay, so let's see. Will it let you clear it out if you hit clear and enter? No, it's not clear. So go up and highlight list 2. We're going to have to clear everything out of here. Clear and enter. Now enter list 2 again. What is the mean for x? 0.4. What's the standard deviation? Thank you. Why is it doing this? Okay, let's try this again. There. Computers. What's the standard deviation? Right about 1.02. I did not round mine that part. I didn't round it out to 2 decimal places, but 2 decimal places is fine. If you did 1.02, that's perfectly fine. And then how do we find the variance again? We take that and we square it. What is the variance? Yep, 1.039, 1.04. I rounded this one. Don't ask me why I rounded this one to a different number of places. I don't have a good answer. How do you find, or not how do you find, but what is the mean, variance, and standard deviation for y? What's our mean here? 2.6. Standard deviation? 0.917. Variance? 0.841, 0.84. Number 3 says let W equal 3 plus 2x. Find the mean, variance, and standard deviation of W using the rules. How does multiplication affect the mean and the standard deviation, or does it? What do you do to the mean when we have multiplication? You multiply the mean. What about the standard deviation? For multiplication, we still multiply. Standard deviation, you multiply. What about the adding and subtracting part? Doesn't affect the standard deviation, but it does affect the mean. So didn't we just find the mean of x? Yes, we did. So to find the mean of W, I'm going to take the mean of x and plug it in for x. Go ahead and calculate the mean for W. So 3 plus 2 times 0.4 would give us what? 3.8. Would everything about this equation for W affect my standard deviation? So what part do I get rid of? We ignore that 3 and the plus sign. We just do 2 times the standard deviation of x. We said the standard deviation was about 1.02, right? So what's the standard deviation for W? About 2.04. And then they also asked us to calculate what? The variance. How do I find the variance again? Square the standard deviation. What's 2.04 squared? 4.16. We're going to construct exactly what W would look like. So here's x. I'm going to use this equation right here, and I'm going to plug each of these x values in and see what we get. And that's going to be a W value. Just kind of like Algebra 1, only we're just going to take different numbers and plug it into the same equation. So if I take -1 and I plug it in here for x, what do I get back for W? 1. What about if I take 0 and I plug it in for x? 3. If I take 1 and plug it in for x, 5. And if I take 2 and plug it in for x, 7. So my possible values for w using this equation are 1, 3, 5, and 7. What are the probabilities? It's the same probabilities. So 0.3, 0.1, 0.5, and 0.1. I want you guys now to use the calculator method, putting them in lists, to find the mean, variance, and standard deviation, just like you did for x and y up here. I want you to put them in the lists and do mean, variance, and standard deviation for w.
What did you put in for x? Did you do the
Nope. We did this, and then we did this, and then we did this, and then we did this. What should we get as the mean? 3.8. Do you get 3.8? Yes. What should we get as the standard deviation? 2.04. I got 2.039. That's 2.04. And so my variance would come out to still be 4.16. I know there's more on this page, but I promised you guys some homework time so that if you had questions, you could ask. So I'm going to stop leading any kind of review right now and give you guys a chance to look at your homework and ask any questions. On problem number 1 on the homework, read the directions carefully. I know a lot of people started on the homework before we had talked about geometric distributions yesterday. You're supposed to look to see if these situations are binomial, geometric, or neither. So if it's geometric, it will meet all of the criteria for a binomial except you're going until the first instead of a fixed number of trials. Pay attention to your 10% condition, because if it meets the 10% condition, we can basically get independence. We can assume independence if we meet our 10% condition.